In this unit, we've talked about translations that slide, reflections that flip, rotations that turn, and today we're going to talk about dilations. Dilations are when a shape reduces or is enlarged. It's called a non-rigid transformation. Rigid transformations stay the same size and shape. They just change their location and orientation. But a dilation changes its size. It either gets bigger or it gets smaller. And it does that by its scale factor. That's the multiplier that causes that dilation. A scale factor that's bigger than 1 is an enlargement, and a scale factor that's between 0 and 1 is a reduction. A negative, if it's negative, it doesn't, that's a reflection, right? So negative is not what causes a reduction or enlargement. This is the absolute value of that scale factor. The notation that we're going to use is we'll say a capital D. So say, for instance, that I want to double my figure, my original figure, then I would have a D with a subscript of 2. We often don't put the XY, but all it means is that your XY in the notation that we have used before, your XY is going to become 2X and 2Y. So that's what your notation will look like. Quite honestly, you're not going to want to memorize this dilation centered at HK through a center that's not 0, 0. That's messy in keeping up with H and K and all of that. You can if you're a rule person and you are good at memorizing, but I'll show you a different way that you can do that type of problem without having to memorize that formula. So let's first look at dilating through 0, 0, what it means when you are dilating, centering through an origin or through another point, is that the pre-image, the original point, the image, which is the new shape, and the center of dilation, they all form a straight line. So if you look at, grab my ruler, if you look at this problem right here, you'll see that it is centered through 0, 0 because I can connect 0, 0 and P prime all in a straight line. I can do R prime and 0, 0 through a straight line, and I can do Q and Q prime through 0, 0 with a straight line. So that is what it means to be centered through 0, 0. Think of this like a projector on the wall. If you were to step between the wall where the movie may be playing and the projector, then it is going to project on you, but it will be smaller because you're closer to it. So this shape is closer to the center of origin or the center of the dilation, and so as it goes out, it's going to be bigger. Now my original shape is PRQ, and then I have P prime, R prime, Q prime. To figure out the scale factor, there are several things that you can do. In this particular case, it's easy because we have straight lines that we can count. So we can go 1, 2, 3, 4, 5, 6. This is 6. This is 2. I started here, then I went here. So I either have a scale factor of 6 over 2, which is 3, or I have a scale factor of 2 over 6, which is 1/3. Sometimes people have a hard time remembering which one goes on top and which one goes on bottom, and that's why I'm showing you both, and then you can look at it and see what makes sense. So my pre-image was big, my image is small. That means it got smaller. That means my scale factor has to be between 0 and 1, so this has a scale factor of 1/3. Another way that you can see it is Q has a coordinate value of 12, 3. Q prime has a coordinate value of 4, 1. If I take 12 and divide it by 3, I get 4. 3 divided by 3 is 1. That's where that 1/3 comes into play. And that will work for all of the points. P here is at 3, 9. And P prime is at 1, 3. R is at 3, 3, and R prime is at 1, 1. So all of the numbers on my image are 1/3 of the numbers that were on my pre-image. It is definitely a reduction, and the rule is basically all of your coordinates are 1/3 as big as they were. It's 1/3 of the X value and 1/3 of the Y value if you want to follow the rules. Now just an interesting, let me show you something, another way to kind of look at it, because this will help for the next problem. What if they're not horizontal? What if you can't count them? What if it's not through 0, 0? So I want you to see that this way applies to everything. So if I start at the origin, and let's do Q. If I do the slope from the origin to Q, I go up 1 over 4. Now, if I do that same thing and I mimic that, that's my smallest one. If I mimic that and go to Q, up 1 over 4, up 1 over 4, up 1 over 4, look at how many times I did that stair step. 3 times. Well, let's go from R to R prime to R. That's up 1 over 1, up 1 over 1, up 1, 3 stair steps. And if we do the same thing for P prime, that's up 3 over 1. If I mimic that, up 3 over 1, up 3 over 1. Notice there's 3 stair steps. So there are 3 slopes between from the origin, from the center of dilation to the farthest out point. And that's one way that also that you can see what that scale factor is this is 1 stair step, that's 3 stair steps. And so the scale factor is 1/3. That could be handy in this next problem where there are no sides. I don't know. I could calculate it, but why? The side length of BC prime and BC. You could, because it is dilated through 0, 0, you can use the coordinates. B prime is at 4, -2, and B, the image, is at 2, -1. If you'll notice, this one is twice as big. 2 times 2 is 4. 2 times -1 is -2. Same thing happens with C. My pre-image is at -2, -2. My image is at -4, -4. So it is twice as big. The same thing would happen for A and A prime. So this has a scale factor of 2. It is definitely an enlargement. Remember, this is where you have to remember it's the A is the pre-image and the A prime is the image. And so we go out. So this one is going out where this one is coming in, right? So it was big, it went small. So don't forget your notation that your point is your original, your point prime is your new image, okay? And our rule then would be is that this is twice as big. We would have xy becomes 2x and 2y because all of them have been adjusted by the same amount. They don't have to be. You could do x by 2 and y by 3. But in our case, most of the time we will deal with the same enlargement. So we will be grabbing that photo by the corner and dragging it out rather than just making it wider or just making it taller. We will affect everything by the same amount. Okay, so let's take a look at some problems with this. ABC is dilated through the origin. How can you tell it's dilated through the origin? I didn't have to tell you that, but you were told, so let's look. If we connect C and C prime, look at where they connect back to. Connects back to the origin. B and B prime. If you look, it connects back to the origin. The reason that's why that's beneficial to recognize is because it allows you to use the rule, right? If you don't have the rule, then you have to use that ugly rule, right? So if it dilates through 0, 0, then we can just use our rule to find our new points. Otherwise, we have to use this, or I'll show you the way that you handle that. But that's the benefit of being able to recognize that it dilates through 0, 0, even if you weren't told that. So that's because 0, 0, the origin, and then B and B prime are collinear. Remember, that meant that they are all on the same line. So that's why. Now, why is that beneficial? Because what it enables me to do is see what my scale factor is. Now, this is a little bit harder because we don't have it, but actually we can just look at our points, right? 2 ways to do this. Let me show you. So B is at 3, -2, and B prime is at 9, -6. Well, if you'll notice, from B to B prime, from my pre-image to my image is 3 times 3 is 9, and -2 times 3 is -6. So my scale factor is times 3. So everything has been multiplied by 3. You'll see that with C. C is at 1, 3, and C prime is at 3, 9. So again, that's the benefit of recognizing that it is dilated through 0, 0. Now just to show you that it doesn't matter, another way to do it is start at your center, go up 3 over 1 in this case. So do it again and then do it again and see how many times you can do it. There's 1, 2, 3 stair steps. 1 stair step to my original, 3 stair steps to my final shape, so it is 3 times bigger. And you can look at it 1 over 3 or 3 over 1, which one makes it bigger, and that's times 3. So then where is A prime located? Well, A, my original pre-image, was at -9, -1, which means that my new one, because it's dilated through 0, 0, I know that all I have to do is apply the rule that xy becomes 3x and 3y. So that makes it easy. I don't have to do a lot of work over here. So it'll be at -27. Oh, excuse me, it's -7, not -9. So that'll be -21, -3. So it'll be off. It'll be way back here and down here a little bit. So then we'll get our nice big triangle. So understanding that it's dilated through 0, 0 is nice because then it allows you to use the rules. You don't have to worry about the stair steps and stuff like that. You can just look at the points, figure out what it took to get bigger or smaller, and find out what your scale factor is and apply it to everything else. So let's look at not dilating through 0, 0. So if it is not dilated through 0, 0, again, your point of dilation, they're all going to be connected. They're all going to be collinear. This figure is dilated through a point other than the origin. How can you tell? Well, if I connect A to A prime, try to do it really straight because we'll need this in a minute. Notice that that line doesn't go back to 0, 0. So the reason that we know that it's not dilated through the origin is because A prime and 0, 0 are not collinear. They're not on the same line. Now, what does that mean? That means we can't use the rule. We can't just multiply all of the original coordinates to find the new coordinate. So how do we find the scale factor? So the scale factor then, the easiest way to do it is that one of the things that's going to be consistent is whatever the scale factor is from A to B, as is from A prime to B prime, is going to be the same scale factor from B to C and A to C. So here's how I recommend that you do it. Use the concept of those stair steps and find the new points. So we have A, B here, we have A prime, B prime here. So here's what I recommend that you do. Okay, let's go over here and let's just figure out. So we're going to see how many, if I go down 4 over 2, that's the slope of AB. So let's break that into 2. Half of 4 is 2 over 1. So that gives us 2 stair steps. Okay, so we have 2 stair steps from A to B. Okay, so there are 2 slopes from A to B, because slope is something that's consistent that we can compare. Then from A prime to B prime is down 2 over 1. So I did the same slope, which they should be, they're parallel. There's only 1 slope. Okay, so I did 2 stair steps here and I did 1 stair step here. So that gives us the scale factor. So we want to look at the one side that we have all the information for. Can't do BC because I don't know where C is. We're going to find that in a minute. Can't do AC for the same reason. So I'm going to go with AB because I have A prime, B prime. 2 slopes on AB, 1 slope on A prime, B prime. So that means it's either 1 over 2 or 2 over 1. So which one? Look, here's your pre-image. This is your original, right? And this A prime, B prime is your new. So it got smaller, evidently went from 2, went to 1. So it got smaller. So that means that 1/2 is my scale factor because the scale factor between 0 and 1 gets smaller. So where is C located? So it doesn't matter whether you use A, C, or BC to find where C is. But we're going to use that same idea. So let's BC will be broken into 2 stair steps because AB was. So So let's figure out where that midpoint is. It's right there. So we're going to go up 1 over 3, up 1 over 3. Now, whatever we did there, we're going to mimic it down here. We're going to, from B to C, we went up 1 over 3, up 1 over 3. So from B, we're going to go up 1 over 3, and we're only going to do it one time because it's 2 to 1. So I'm going to do it one time, and that's going to put my C prime right there at 1, 2, 3, 4, 1, 2, 3. Okay, so that one's a little more, so it's a little more intensive as far as like the thinking that you have to do. But this same thinking does work when it's dilated through 0, 0. So you can just use this thinking all the time. You can always just count your slopes, count your number of stair steps. Okay, so I did. So how did I get it? So first I found out what's the slope of A to B. I split it into as many slopes as I could, how many stair steps, and then I compared 2 slopes here to 1 slope here. I knew that all 3 sides, I could do the same thing. Let me show you. I could do the same thing here. If I split AC into 1, 2 stair steps, it was down 1 over 4. I could go down 1 over 4 from A, and I will still end up here at C. So it didn't matter. I went from B to C. I don't know any particular reason. I just went from B to C. 2 stair steps, 2 stair steps, 2. This, everything in this is going to have 2 stair steps. Everything in this is going to have the matching singular staircase. This was down 2 over 1, so that's down 2 over 1. This was up 1 over 3, so this one was up 1 over 3. If you could have done this one, down 1 over 4, down 1 over 4. Either one, you would have ended up at the same place. So where is the center of dilation? Well, let's just backtrack and find out where they all meet. So if you do it carefully, now you got to be careful about it, you can line up all your points. And you can see where they meet. Now if those 2 meet right here, guess what? The other one will meet right there also. Let me prove it. And you can backtrack and you can see where it is. You could go from B to B prime and then mimic that, do it one more time, and that'll tell you where that center of dilation is. So the center of dilation is at 8, -1. So remember, the center of dilation, your pre-image, your image, and your center of dilation will all be in a straight line. They'll all be collinear. So you can connect the dots and then figure out where they all intersect. So that's how you find your center of dilation. So let's take a look at a problem that kind of does 2 different things. So this kind of summarizes everything. ABC has vertices of A, -2, -2, B is 1, -1, and C is at 0, 2. Let me show you the difference, what it looks like to dilate through 0, 0. Same figure, but 2 different dilations. So -2, -2, there's A. B is at 1, -1, and C is at 0, 2. If you're going to draw your figures, please label them with the letters. That's your pre-image. We're going to use a scale factor of 2. The first one says to find the new image, right? Find the image of A prime, B prime, C prime after a dilation about the origin. That gives you permission to use the rules, right? So my rules then would be X, Y becomes, I want a scale factor of 2, 2 times X and 2 times Y. So if I take all of my X and Y values and multiply them by 2, so A would be at -4, -4. Go ahead and plot that. B will be at 2, -2. B prime, there's A prime. And C prime will be at 0, 2, so, or C prime will be at 0 times 2 and 2 times 2, so 0, 4. So there's C prime. So here is what it looks like in this case to be dilated through 0, 0. Okay, and we can use the rule. Now, what if it's not dilated through 0, 0? Same points. Let's go back and put those on there. And let's dilate it through -5, -4. Okay, so let's put -5, -4 on the graph. Okay, so that's my center of dilation. So here's what you want to remember. Remember that we want to do a scale factor of 2. Remember that they all have to be connected. So here's what you do. You go from your center of dilation. Let's just draw it in so you can see it. Okay, so that's what it'll look like. Okay, that's the line that connects them. Remember, they're all collinear. So now let's just see how far does it go from the center of dilation to A? Up 2/3. Now, if we want to use a scale factor of 2, then we just need to do that twice. So up 2/3, let's do it another time, up 2/3. Right there is my new A prime. Okay, we're going to do the same thing with B, and you don't have to connect them, but I just want you to see these perspective lines. So from the center of dilation to B is up 1, 2, 3 over 1, 2, 3, 4, 5, 6. So we'll do it again, up 1, 2, 3 over 1, 2, 3, 4, 5, 6. That's where your new B prime is going to go. And then we need our C prime. So if you want to connect them, you can, just to give you an idea of where you're going. Make sure you're doing your right work. From C, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Do it again. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So there is your image of C. So my final shape will look like this. So that is what the difference is when you dilate through 0, 0 and when you dilate through a point not 0, 0 at the same time. Now, one of the reasons it did this, like it grew out, kind of like when you do your phone, right? That's actually your center of dilation. So notice the center of dilation is in the center of the shape. That's why it went like this. Whereas if you do the side of your phone and you zoom, it's going to go out like that. So if it just all depends on where the center is in regards to the shape. But in this case, the origin was in the center of the shape, which is why the shape stayed centered around 0, 0. Okay, so now we see that A is at 1, 0, B is at 7, 2, and C is at 5, 8. So when it is not centered through 0, 0, you want to count slopes. And when it is centered through 0, 0, you can count slopes, or you can just use that scale factor and multiply your x and your y by that scale factor.